Йо-йо-йо, один какой-то там 834. Букерки жжет. Здорово, ребята, девчата. Рад вас приветствовать на очередном эфире по SwiftUI. Что мы делаем? Мы продолжаем КВН, шутка, мы продолжаем проходить курс по SwiftUI, 100 дней SwiftUI. В прошлый раз, можно сказать, закончил день 91. Осталось выполнить челлендж. Вот эту конкретно третью часть. Я ее не буду выполнять в эфире. Я потом выполню ее без эфира и покажу результат вам. Поэтому на данный момент я перехожу к дню номер 92. Дню номер 92. Здесь у нас начинается новый проект, насколько я помню. Это он касается геометрии, лейаутов и так далее. Давайте тогда приступать. Я фиксирую данную информацию. И мы полетели. Проект 18, часть 1, введение. В нашем последнем техническом проекте за эти 100 дней мы рассмотрим, как SwiftUI обрабатывает макет и геометрию. Лейауты и геометрию. Да, я понимаю, что вы могли ожидать, что подобные вещи будут рассмотрены гораздо раньше, но одна из замечательных особенностей SwiftUI заключается в том, что он делает для нас так много работы, То, что этот вид руководства появляется так поздно в этой серии, свидетельствует о том, насколько хорош стандартный макет SwiftUI. Автор комикса X Cassidy Рэндалл Монро однажды сказал: если вы действительно кого-то ненавидите, научите его распознавать плохой кернинг. Это такое пространство между буквами. Если вы еще не знали, кернинг — это интервал между буквами, и плохой кернинг встречается на удивление часто. Как только вы научитесь его замечать, вы поймете, что он повсюду. Сегодня вы будете рассматривать выравнивание. Это еще одна вещь, которую трудно игнорировать, когда вы, конечно, когда вы знаете о ней. Конечно, легко заметить, когда одна вещь центрирована, а другая нет. Но что, если две вещи выровнены по немного разным ведущим краям? Это невидимо, пока вы не знаете об этом, но когда вы начинаете замечать, то уже невозможно остановиться. Сегодня 5 тем, в которых вы узнаете о правилах макета, о выравнивании пользовательских направляющих и многом другом. Окей, давайте посмотрим. Alignment, выравнивание, да. Окей. Тогда что мы? Тогда мы без... Почему? 93, это тут такой вот. Окей. Готовы. Так, что у нас? Первая часть этого дня. Layout и геометрия введения. Переводим на понятный нам язык. Более понятный. В этом техническом проекте мы собираемся изучить, как SwiftUI обрабатывает макет. Некоторые из этих вещей уже были немного объяснены. Возможно, некоторые из них, возможно, вы поняли сами, но многие другие вещи, это, возможно, вы, возможно, просто принимали как должное до этого момента. Поэтому я надеюсь, что подобное исследование действительно прольет свет на то, как работает SwiftUI. Попутно, сейчас мне надо попутно еще кое-что сделать. Это работает. Работает. Пропусков вроде бы нет. Попутно вы также узнаете о создании более сложных выравниваний макетов, создании спецэффектов с помощью GeometryReader и многом другом. Некоторых действительно мощных функциях, которые, я уверен, вы захотите использовать в собственных приложениях. Создайте новый проект iOS, используя шаблон App, назвав его Layout and Geometry. Вам понадобится изображение в вашем каталоге ресурсов, чтобы следовать главе пользовательских направляющих уравнений. Но это может быть все, что вы захотите. На самом деле это просто заполнитель. Placeholder. Go ahead. Просто можно сказать, давайте создадим go ahead and create. Окей. Следующее упражнение. Берем мячи. Следующий урок, точнее видео, да. How layout works in SwiftUI. Как макет или слои вот эти работают в SwiftUI. Давайте посмотрим. 9 минут. Будем смотреть на ускоренном.
SwiftUI layout whole screen.
Сразу наконец нам не надо.
All SwiftUI layout happens in 3 simple steps. And understanding these steps is the key to getting great layouts every time. The steps are: First, a parent proposes a size for its child. Second, based on that information, the child then chooses its own size, and the parent must respect that choice. And third, the parent then positions the child in its coordinate space. Now, behind the scenes, SwiftUI performs a 4th step, although it stores positions and sizes as floating point numbers. When it comes to rendering, SwiftUI rounds off any pixels to the nearest values, so our graphics remain sharp. Now, those 3 rules might seem simple, but they allow us to create a hugely complicated layouts where every view decides how and when it resizes without the parent having to get involved. To demonstrate these rules in action, I want to make a very, very simple text view here with a background modifier. I'll say text hello world with a background of red. Now, you can see in my preview here, the background color sits tightly around the text itself. It takes up only just enough space to fit the content we provided. Now think about this question. How big is content view? Now, as you can see, the body of content view, the thing it renders on the screen, is some text with a background color. And so the size of content view is exactly and always the size of its body, no more and no less. This is called being layout neutral. Content view doesn't have a size of its own, actually doesn't really exist at all as a thing, at runtime at least, and instead just happily adjusts to fit whatever size is needed. Now, way back in Project 3, I explained to you that when you apply a modifier to a view, we actually get back a new view type called modified content, which stores both our original view and its modifiers. This means when we apply a modifier, the actual view that goes into the hierarchy is the modified view, not the original one. So, in our simple background example, that means the top level view inside content view is the background. And inside that is the text. Backgrounds are layout neutral, just like content view. So it'll just pass on any layout information as needed. You can end up with a whole chain of layout information being passed around until a definitive answer comes back. Now, if we put this into the 3-step layout system, we end up with a kind of a conversation, a bit like this. So if UI is going to say, hey, content view, you have the whole screen to yourself. How much of it do you need? So the parent view is proposing a size. Content view says, well, listen, I don't actually care. I'm layout neutral. I'm going to ask my child, hey, background, you have the whole screen to yourself. How much of it do you need? Parent view proposes a size. The background says, well, I don't care as well. I'm also layout neutral. Let me ask my child, hey, text, you can have the whole screen to yourself. How much of it do you need? Parent view proposes a size again. The text says, well, I have the letters HELLO, comma, space, WORLLD, exclamation mark, in the default font. And so I need X pixels wide by Y pixels high. I don't need the whole screen, just that. So the child is now choosing its size. This goes back up to the background. Background's like, okay, got it. Hey, content view, I need X by Y pixels, please. And so content view says, okay, right on, dude. Hey, SwiftUI, I need X by Y pixels. And so SwiftUI says, okay, nice. That leaves lots of space. So I'm going to put you at your size you requested in the center of the available space. And that's the parent positioning the child in its coordinate space. And so when we say text hello world like this, background red, our text view becomes a child of its background. SwiftUI effectively works its way from the bottom to the top when it comes to a view and its modifiers. Now consider this layout. Text hello world, padding of 20, then background red. And this time the conversation is more complicated because padding no longer offers all its space to its child. It needs to subtract 20 points from each size to make sure there's enough space for the padding. And then when the answer comes back from the text view, padding adds 20 points on each size to pad it out as requested. So it's more like this. SwiftUI says you can have the whole screen. How much do you want? Content view. Content view says, well, you can have the whole screen. How much do you want? Background. Background says, hey, you can have the whole screen. How much do you want? Padding. Padding then says, you can have the whole screen minus 20 points on each side. How much do you want to the text? Again, text is X by Y. Padding reports back X by Y plus 20 points on each side. The background then passes that on, X by Y plus 20 points. Content view says X by Y 20 points. And SwiftUI then sends the result. Now, if you remember, the order of our modifiers matters, which means the code of background with padding 20 and background with first, then padding 20 yield different results. And hopefully now you can see why. Background is layout neutral. It determines how much space it needs by asking its child how much space it needs and using that same value. So the child of background is the text view, which is now directly, then it'll fit snugly around the text. But when the child is the padding around here, then it will receive back the adjusted values that include the padding amount. Now, there are two interesting side effects that come as a result of these layout rules. First, if your view hierarchy is wholly layout neutral, then it will automatically take up all available space. For example, shapes and colors by default are layout neutral. So if your view contains a color and nothing else, it'll automatically just fill the screen. I could say here, let's just use color.red, bang, full screen straight away, just expands the fill. Remember, color.red's a view in its own right. Because it's layout neutral, it can be drawn at any size. And when we use it inside background, the abridged conversation kind of means this. The background says, hey, text, you can have the whole screen. How much do you want? Text has X by Y points. I don't need the rest. The background then says, hey, color.red, you can have X by Y points. How much of that do you want? And it'll say, I don't care. I'm layout neutral. X by Y points sounds good to me. The second interesting side effect is one we faced earlier. If we use frame on an image that's not resizable, we get a larger frame without the image inside changing size. This might have been confusing before, but it makes absolute sense once you think about it, because the frame is the parent of the image.
Еще разок.
I'm layout neutral. X by Y point sounds good to me. The second interesting side effect is one we faced earlier. If we use frame on an image that's not resizable, we get a larger frame without the image inside changing size. This might have been confusing before, but it makes absolute sense once you think about it, because the frame is the parent of the image. Content view will offer the frame the whole screen. The frame reports back, it says, I want 300 by 300. The frame asks a child inside it what size it wants, and that image not being resizable will say, hey, I want 64 by 64, for example. And that frame then positions the image inside the center of itself, 64 by 64 inside 300 by 300. Now, when you listen to Apple's own SwiftUI engineers talking about modifiers, you'll hear them refer to them as views. They'll say the frame view, the background view, and so on. And I think that's a really great mental model to help understand what's going on here. Applying modifiers makes new views rather than modifying existing views in place.
Это есть. Следующее упражнение. Alignment. Alignment and alignment guides. Это будет пусть 14 минут. Окей, полетели. Выравнивание и направляющее выравнивание. 8 минут.
SwiftUI gives us a number of valuable ways of controlling the way views are aligned, and I'll walk you through a few of them here so you can see them in action. The simplest alignment option is to use the alignment parameter of a frame modifier. Remember, a text view always uses the exact width and height required to show its text. When we place a frame around it, that can be any size. As the parent doesn't have a say in the final size of the child, we can make some code, make a 300 by 300 frame with a smaller text view inside centered. I'll say here we have the text, let's do live long and prosper, with a frame width of 300 and a height of 300. Now, if you don't want the text to be centered, you want to add the alignment parameters of the frame modifier. For example, you could write some code to place this view in the top left corner when running a left to right environment. I'll say here, that's our frame size with the alignment of dot top leading. And you can see it moves to the top left corner straight away. You can then use offset XY to move the text around inside the frame. Now, the next option up is to use the alignment parameter of a stack. For example, we could make 4 text views of varying sizes in a H stack. So we'll replace this code here with a H stack saying text. Let's do live in a small font of caption that's quite small. Then a text of long in a regular font. then text and in a font of title, then a text of prosper in a font of large title. There we go. Now we haven't specified an alignment here, so they're going to be centered by default inside the H stack. It doesn't look great. So you might think to align them all to one edge to get a neater line. You might say let's do a H stack here with alignment of bottom. But that also looks bad because each of the text views has a different size and they have a different baseline. Now, baseline is a name for where letters like A, B, C, D, E sit on a line, the bottom of the line, A, B, C, D, E. But that excludes the part of the letters that go below the line, like a G or a J or a P or a Y. They have what we call a descender that goes below the baseline. As a result, the bottom of the small text here sits lower than the bottom of the large text below, next to it. Now, fortunately, SwiftUI has two special alignments that align text on the baseline of either the first child or the last child. This will cause all views in the stack to be aligned in a single, unified baseline. So rather than saying alignment bottom, I'm going to say alignment is the last text baseline. And now they'll all sit on the same line. It's real close, but if you just zoom in like that, you can see, boom, they just sit on that same invisible little line there like that. Moving on. For more fine-grained control, we can customize what alignment means for each individual view. Now, to get a really good idea of how this works, we're going to start with some slightly different code. That's the app we have right now. We're going to say we have a VStack with alignment of leading. This will contain a text, hello world. Then the text of, this is a longer line of text. I'll then place that into a background with red behind it, then a frame width 400, height 400, and then a background of blue. So you can see the VStack itself sits tightly around the two pieces of text with a red background. These two text views have different lengths, but because we use the leading alignment here, they'll both be aligned to the left edge in a left to right environment. Outside of that is the larger frame here has a blue background. And as that frame is larger than the VStack is centered in the middle. So you can see it's a red block and then a blue block around it. Now, when the VStack comes to aligning each of these text views, it's going to ask them to provide their leading edge. And by default, this is obvious. It uses either the left or right edge of the view, depending on the system language. But what if we wanted to change that? What if we want to have one view with a custom alignment? And SwiftUI provides us with the alignment guide modifier for just this purpose. This takes two parameters. First, the guide we want to change, and second, a closure that returns a new alignment. And this closure is given a view dimension object that contains the width and height of its view, along with the ability to read its various edges. Now, by default, the leading alignment guide for a view is its leading alignment guide. I know it's obvious, but it's effectively equivalent to saying exactly this. We're going to say that we have, for this text, hello world, the alignment guide for leading. Give me the value coming in here, like this. So give me our current dimensions. And use those dimensions to send back the current leading alignment guide. So again, the leading alignment guide is the leading guide. It's obvious, but it doesn't matter. Use that for the leading alignment guide. But we can actually rewrite this to say, actually, I want to use the trailing edge of the view for its leading alignment guide. What it means is, I just say, when you ask for leading, send back trailing. And now, you can see why I had colors. The first text view is going to move over to the left, so it sits directly above the left edge of the text below. The VStack will then expand to contain it, and the whole thing is still centered within the blue frame. Now, this result is different from using the offset modifier. If you offset a text from its original dimensions, from its original position, the dimensions don't actually change, even though the resulting view is rendered in a different location. That's a rendering location. The actual frame has not changed. If we'd offset the first view rather than changing its alignment guide, then the VStack wouldn't expand to contain it. Now, although the alignment guide closure is past your view's dimensions, you don't have to use them. If you don't want to, you can send back a hard-coded number or make some other calculation. For example, we can make a tiered effect for text views by multiplying a position by -10 as we work our way through. So I'll say, let's delete some code here. So no more hello world. Instead, I'm going to say we have a for each of 0 to 10 with one position coming in. Let's do a text view saying number, then that position, like so. But I'll add an alignment guide here with the leading edge being computed. We'll get dimensions passed in, we'll happily ignore those. I'm going to say alignment guide for leading edge is the double of our position times by -10. And now we get this sort of tiered approach here. They move themselves across the way as they need to. for complete control over your alignment guides, you've got to make a custom alignment guide. And I think that deserves a mini video all of its own.
В целом, все точно то же самое, что и было. Но все равно полезно посмотреть, почитать. Конечно, я начинаю уже клевать носом, но ничего, сейчас взбодрюсь. И полетим дальше. А дальше у нас видео How to create a custom alignment guide.
SwiftUI gives us alignment guides for the various edges of our view. That's things like leading and trailing, top, and so on. Plus we have center and 2 baseline options to help with text alignment. However, none of these work well when you're working with views that are split across disparate views, if you have to make 2 views aligned the same somehow when they are entirely different parts of your user interface. And to fix this, SwiftUI lets us create custom alignment guides and use those guides in views across our UI. It doesn't matter what comes before or after these views, they will still line up. For example, we can make a layout that shows my Twitter account name and my profile picture on the left of a HTAG, and on the right show full name plus Paul Hudson in a large font. So I'll say here in our view body, we have a HTAG. Inside there is a VStack on the left with the text of @2straws, my account name, and then an image I added earlier, which is a picture of me, Paul Hudson, nice and big right now. I'll make it resizable and then give a fixed frame width of 64, height 64. Then on the other side of the HStack, we'll do a VStack here with the text of full name, colon, and then the text of, quotes please, Paul Hudson in a font of large title. Now, if we want to have this 2 straws and Paul Hudson be vertically aligned together, you're going to have a hard time right now. This horizontal stack contains 2 vertical stacks inside it. There's no built-in way to get the alignment you want. Things like saying, oh yeah, HStack alignment top, they just won't come close. Yeah, nowhere near. To fix this, we're going to find a custom layout guide, and this should be an extension on either vertical alignment or horizontal alignment, depending on what you're trying to do, and be a custom type that conforms to a protocol called alignment ID. Now, when I say custom type, you might be thinking of a struct, but it's actually a good idea to implement this as an enum instead, and I'll explain why shortly. The alignment ID protocol has only one requirement, which is that the conforming type must provide a static method called default value in that accepts a view dimensions object and returns a CG float, specifying how a view should be aligned if it doesn't have a custom alignment guide modifier. You'll be given the existing view dimensions object for the view, so you can either pick one of those for your default or use a hard-coded value. Let's write out the code so you can see exactly how it looks. I'm going to say there's an extension on vertical alignment. Inside there will be a new struct called mid account and name, which conforms to alignment ID. And then we'll implement that default value in method right here. What am I reading? If there's no alignment guide, what's the default if there isn't one? And we'll just say, we're giving this context right now of our current view dimensions, just send back the top dimension. That's fine. A good, safe default. I'll then make outside of this a constant that wraps this in a vertical alignment object for easier access. So I'll say static let mid account and name be a vertical alignment here, which wraps a mid account and name .self struct. So you can see I'm saying use the top view dimension by default, and we have this static constant mid account and name, so the custom alignment guide is easier to use. Now I mentioned that using an enum is preferable to a struct, and here's why. We just made this new struct here called mid account and name, which means we could, if we wanted to, make an instance of the struct, even though doing so makes no sense. It has no functionality built in. But if you replace struct mid account and name with enum mid account and name, we can no longer make one of these things. It becomes clear that this thing only exists to house some functionality. Now, regardless of whether you choose an enum or a struct, its usage stays the same. We set this thing as the alignment for your stack, then use an alignment guide to activate on any views you want to align together. This is only a guide. It helps you align views along a single line, but doesn't say how they should be aligned. This means you still have to provide the closure to alignment guide the positions of views along that guide however you want. For example, we could make our Twitter code use mid account and name, then tell the account and name to use their center position for the guide. And so to be clear, we're saying here, align these 2 views so the centers are both on the mid account and name guide. And so in code, our HStack will have alignment using that .mid account and name value. And when it comes to aligning things inside there, when it comes to the two straws part here, I'll say you have a custom alignment guide for mid account and name. And what you're going to do is say, give me the dimensions coming in and send back the D with a vertical alignment guide of center. So send me back this center value for your positioning. Now we've got to be clear here because it's like, well, there's a horizontal alignment, vertical alignment. This is actually definitely a vertical alignment. So we'll be clear like that. And then we have our image. That's not changing. Then we have a full name. That's not changing. But the text Paul Hudson is changing. Again, we have an alignment guide here. And I literally paste this one we had before. For mid account and name, give the dimensions in, return the center of this view, like so. And now you're seeing these two are vertically aligned along that line, regardless of what comes after them here or before them here. I suggest you try adding some more text views before and after our examples, because you want to see SwiftUI position everything to make sure the two we aligned stay that way.
Окей, здесь тоже ничего нового, но это тема, которую, периодически я бы переслушивал. Вообще вот все эти уроки переслушивал бы и практиковался бы, чтобы немного улучшать свои навыки в этой сфере. Тем временем мы начинаем последнее видео этого дня. Это абсолютное позиционирование представлений в SwiftUI.
SwiftUI gives us two ways of positioning views. We have absolute positions using a position modifier and relative positions using the offset modifier. And they might seem similar at first, but once you understand how SwiftUI places views inside frames and the underlying differences become much, much clearer. Now, a simple SwiftUI view, of course, just something like this, text, hello world, whatever, right? And SwiftUI will offer the full available space to content view, which in turn passes on to the text view. The text view automatically uses only as much space as it needs, so it passes that back up to content view, which is always and exactly the same size as its body property, so it directly fits around the text. As a result, SwiftUI centers the words text hello world, centering content view's body in the available space, which from a user's perspective means the text is in the center of the screen. Now, if you want to absolutely position a SwiftUI view, you want to use the position modifier. For example, we might say text hello world should be at the position x100, y100. And I'll position it there. There it is. Boom, x100, y100. But to really see what's happening here, I want you to add a background color before the position. So I'll say here as a background of .red. And you'll see now our text has a red background tightly fitting around it. Now try moving the background red after position. And you'll see that. You'll see the whole text area becomes red, the whole safe area, everything's red, the whole screen's red, but the text in the same location. And understand what's happening here. You've got to remember that three-step layout process from SwiftUI. Remember again, the parent view processes size for its child, then based on the information the child chooses its own size, and the parent must respect that choice, and finally the parent positions the child in its coordinate space. So the parent is responsible for positioning the child, not the child. This causes a problem. We've just told our text view, you've got to be at the exact position right here, so how can SwiftUI resolve this? And the answer to this is also why our background color made the whole screen red. When we use position like this, we get back a new view that takes up all the available space. So it can then position its child, this text, at the correct location. When we use text, position, then background, the position will take up all the available space so it can place its text correctly. And the background will use that size for itself. On the other hand, when we use text, then background, then position, the background will use the text size for its size. And then position will take that and make all the available space and put that in that one location in the top left corner. Now, when discussing the offset modifier earlier, I did say to you, if you offset some text, its original dimensions don't actually change. Its frame doesn't actually change. Even the resulting view is rendered at a different location. With that in mind, let's try running slightly different code here. I'm going to say, rather than using position, I'm going to say offset at that, and then background red. And now you can see the text appears in one place and the background in another. I'm going to explain why that is. But first, I want you to think about it yourself. If you understand that, then you really understand how SwiftUI's layout system works. When we use this offset modifier, we're changing the location where a view should be rendered without actually changing its underlying geometry. This means when we apply the background afterwards, it uses the original position of the text, not its offset. So if you move the modifier order so that background here comes before text, like that, then things work more like you might have expected, showing once again modifier order matters.
Совершенно верно. Совершенно верно. Порядок модификаторов имеет значение. Ну, а на этом закончился первый день. А именно 92-й день. О чем мы напишем везде, где обычно мы это делаем. Девяносто какой? Второй. Опа. Это, кстати, было в марте, 7 марта, то получается, наверное, это уже и... Наверное, это уже обновленный курс был. Может быть, нет. Ну, раз уже я прохожу по порядку. Так, есть. Переходим дальше. Следующее упражнение. Берем мячи. Начинаем день 18. День 18. День 93, проект 18, часть 2. Что нам здесь сегодня он рассказывает? Сегодня продолжим технический проект по View Layout по макету, исследуя одно из самых мощных представлений макета, доступный нам GeometryReader. Оно позволяет считывать нам размер и положение представления во время выполнения и продолжать считывать эти значения по мере их изменения с течением времени. Я понимаю, что это звучит, возможно, не очень-то особенно, но это открывает дверь к ряду увлекательных эффектов, которые выглядят великолепно и требуют всего 1 или 2 строк кода для создания. Да, 1 или 2. Как только вы поймете, как GeometryReader работает, я очень надеюсь, что вы сможете выделить время на эксперименты. Как однажды сказал британский поэт Уильям Блейк, истинный метод познания – эксперимент. Так что, если вы действительно хотите, чтобы эта информация застряла у вас в голове, вам стоит с ней поиграться. Сегодня 4 темы. Узнаем о системах отсчета, координатных пространствах, GeometryReader и многом другом. Stick in your head. Окей, у нас что? У нас 4 темы. И мы начнем с первой темы. Первая тема – это изменение размера изображений чтобы оно помещалось на экране с использованием GeometryReader.
SwiftUI lets us create views with exact sizes. For example, we could say here in our view body, I'm going to render an image with an example image inside. I'll make this thing resizable. I'll make this thing be scaled to fit. And I'll give this thing a fixed width of 300 and a fixed height of 300. Now, all this works great if we want to have fixed sized views. But very often we want images that will automatically scale up to fill more of the screen in one or maybe both dimensions. And that is, rather than saying I want exactly 300 points of width, what you really want to say is make this image fill 80% of the width of the screen. One option is to use the container relative frame modifier, which we covered back in Project 8. But SwiftUI also has a dedicated type for this work called GeometryReader, and it's remarkably powerful and fills in places where container relative frame won't work. We'll go into much more detail on this thing shortly, but for now, what we need to do is exactly one job to make sure our image fills some percentage of width of its container view. GeometryReader is a view just like all the others we've used so far, except when we make it, we'll hand it a geometry proxy object to use. This lets us query the environment. How big is the container? What position is our view in? Are there any safe area insets? And so on. In principle, that seems simple. But in practice, you've got to use GeometryReader very carefully because it'll automatically expand, take up all the available space in your layout, and then position its own content aligned to the top left corner. For example, we can make an image that's 80% the width of the screen with a fixed height of 300. We can wrap this image here in a GeometryReader with that proxy coming in, like so. You'll see it jump straight away, top left corner, like I said. And then for the image's width, I'm going to say use a proxy.size.width times 0.8. So it'll be now 80% the size of the screen. If you want to, you can even remove the height entirely. We're giving SwiftUI enough information that it can automatically figure out the height for us. It knows the original width of the image. It knows our target width. That's this one here. It knows our content mode. It's scaled to fit. So it understands how the target height of the image will be proportional to the target width. Now, at this point, you're probably wondering, how is this any different from using a container relative frame? The problem is that container relative frame has a very precise definition of what constitutes a container. It might be the whole screen. It might be a navigation stack. It might be a list or a scroll view and so on. But it won't consider, at least at the time of writing of this thing, that a H stack or a V stack is a container. They'll be ignored as containers. This has caused all sorts of problems when using views in stacks because you can't easily subdivide them using container relative frame. For example, we could write some code to place two views in a H stack, one be given a fixed width and the other using container relative frame. So I'll say here, let's replace GeometryReader with a H stack. Start of that as a text important with a frame width of 200 and a background of blue, like so. But the image, of course, we haven't got access to the geometry proxy anymore. So I'll say instead, this thing has a container relative frame using the horizontal axis. Give me the size and the axis coming in. And I'll say your size should be the container size times 0.8. And that's not going to lay out well, as you can see, because this container relative frame looks for the nearest container, and it's not the H stack. That does not count as being a container here. So it looks up to read the whole screen width for its size, meaning this image is made 80% the size of the screen, despite this text next to it requiring 200 points. On the other hand, using a GeometryReader here will subdivide the space correctly. If we say, for example, this thing is wrapped in a GeometryReader with a proxy coming in, like so, and then replace this container relative frame with a regular frame, using the width of our proxy.size.width times 0.8. Now, that is now laying out better. The image is now visible on the screen. The text isn't being pushed off the screen anymore, but it has a different problem. Our image is now aligned to the top left corner of our GeometryReader. Fortunately, this is easily solved. If you ever want to center a view inside a GeometryReader, rather than align to the top left corner, which is the default, add a second frame that makes it fill the full space of the container. So here we have our current frame. Below that, I'll say we have a frame here with a width of our proxy.size.width and a height of our proxy.size.height. And boom, it's centered all correctly.
Окей. Тоже все это уже имеется. Поэтому мы переходим к следующему видео. Understanding frames and coordinates inside GeometryReader.
SwiftUI's Geometry Reader allows you to use its size and coordinates to determine a child view's layout, and is a key to creating some of the most remarkable effects in SwiftUI. You should always keep in mind SwiftUI's 3-step layout system when working with Geometry Reader. First, the parent proposes a size for the child. Then the child uses that to determine its own size. And finally, the parent uses that to position the child appropriately. In its most basic usage, what a Geometry Reader lets us do is read the size that's proposed by the parent, then use that to manipulate our view. For example, we could use a Geometry Reader to make a text view take up 90% of the available width regardless of its content. We could say down here, we have a Geometry Reader with a proxy coming in. Then inside there is a text, hello world, like so. I give this thing a frame width of proxy.size.width times 0.9, then a background of red so it's nice and visible. So this proxy parameter that comes in is a geometry proxy object. It contains a proposed size, any safe area insets that have been applied, plus a method of reading frame values we'll look at in a moment. Now, Geometry Reader has an interesting side effect that might catch you out at first. The view that gets returned has a flexible preferred size, which means it'll expand to take up more space as needed. You can see this in action if you place this Geometry Reader into a VStack like this, and then just try and place some text below it. So down here, text, more text, with a background, with a background of blue. That you can see it's pushed down to the very bottom of the screen because the Geometry Reader is taking up all the remaining space. And you can see it yourself in action. Just add a background green, for example, to the Geometry Reader, and you'll see it filling up all the space. Now, this is a preferred size, not an absolute size, so it means it's still flexible depending on what its parent allows. Now, when it comes to reading the frame of a view, Geometry Proxy does provide a frame-in method rather than simple properties. This is because the concept of a frame includes x and y coordinates, which don't make much sense in isolation. Do you want the view's absolute x and y coordinates, or the x and y coordinates compared to their parent? SwiftUI calls these options coordinate spaces, and those two in particular are called the global space, which is measuring our view's frame relative to the whole screen, then the local space, which is measuring our view's frame relative to its parent. We can also create custom coordinate spaces by attaching the coordinate space modifier to a view. Any child of that view can read its frame relative to that coordinate space. To demonstrate how these coordinate spaces work, we're going to make some example views in various stacks. Attach a custom coordinate space to the outermost view, then add an on-tap gesture to one of the views inside it so we can print out the frame globally, locally, and using our custom coordinate space. Let's try that now. First things first, I'm going to make an inner view, doing a lot of the work here. We'll say there's a struct called inner view, which is a view. The body for this thing is a H stack containing the text of the word left, then a Geometry Reader with a proxy coming in, with a text saying center. I'm either saying a background blue so you can see how it stands out on the screen. We'll then add to the text an on-tap gesture. It'll print out various coordinate information. We'll say, for example, that the global center is string interpolation proxy.frame in the global coordinate space dot mid-x. So the middle x position of this proxy, which is the whole space the geometry is attached to. That's the x, and I'll do x and the same thing for mid-y. So we know how much space it takes in x and y coordinates. I'll then copy and paste this twice more. So we have once here, and like that. And we're going to say that actually this second one isn't the global center, it's a custom center. And the last one is a local center. So different coordinate spaces. And so now rather than saying frame in global here and here, this needs to be frame in dot a named namespace called custom. And the same down here, like that. So, two named coordinate spaces, both called custom like that. Then for our local center, we'll use dot local. So relative to the parent rather than relative to the screen edge, like that. And that's our inner view. I'm going to wrap around that an outer view. And this thing, again, it's a view. This thing will have a VStack with a text of top. Then our inner view with a background color. Here, background of just green is fine. Then a text of bottom, like that. And finally, we can go ahead and use our main content view, this one here, delete all its current code, and say instead, I want an outer view here with a background of red, and then a coordinate space called custom. That define a coordinate space attached to this thing. That's more or less correct. I think I made a few small mistakes here. Let's try and fix them up real fast. I'm going to make this slightly better. I want to write text after the geometry reader, like this. There we go. I'll also color the geometry reader a different color so you can see it stand out. Let's do background orange, like so. Beautiful. Okay, go ahead and run the code. Just press Command R, run the code back, see what you think. When you're ready, press center, and I'll print out all our values here. And they're somewhat similar, but some interesting variations. I'll hopefully show you the full range of how these frames work. We've got this global center of 191, meaning the center of our geometry proxy, this thing down here, center vertically here is 191 points. So center horizontally, sorry, center X 191. 191 points from the left edge of the screen. Now, it's not the dead center because the word left is smaller than the word right. There's actually more spacing here, so it actually occurs just a bit to the left of the actual center of the screen. We then have a global Y center of 440. So the center of this thing is 440 points down the top edge of the screen. Again, not dead center of the screen. In this case, because on my device, an iPhone 15 Pro, there is more safe area at the top than there is at the bottom. So it's actually pushed slightly down the way. Then we've got a custom center of X here. This means, again, we're the left edge of whichever view owns that custom coordinate space, which for us is the outer view. And that attaches to the most outer view we have, and therefore it also goes edge to edge horizontally. So it's the same number as our global center, that hasn't changed. But we do have a custom center Y of 381. This value is smaller than the global of 440 because outer view does not extend into the safe area. Then we have a local center X of 153. The center of the geometry reader is 153 points from the left edge of its direct container. And then we have the local center Y of 350, the smallest value for the Y here. So again, that's 350 points from its direct container. Now, which coordinate space you want to use depends on what question you want to answer. Do you want to know where the space is on the whole screen? Use the global space. Do you want to know where this view is compared to its parent? Use the local space. Do you want to know where this view is relative to some other view? That's where you use a custom space.
Что я могу сказать по итогу этого? Это у нас что? Это у нас proxy frame in global. Custom. И третий это local. Так, окей. Следующее. Конечно, такой скучный проект. Это просто, я засыпаю. Сейчас, секундочку, я отлучусь, вернусь. Нужно просто хотя бы дверочку открыть, чтобы мне воздух сюда заходил. Это что-то. Так, я вернулся, подышал немного свежим воздухом и включил вытяжку. Здесь у меня в комнате, ну, типа вентиляция. Там она вытягивала воздух, и будет приток свежего воздуха, надеюсь. Потому что в закрытом помещении у меня здесь окон нет в этом офисе. В этой комнате. Поэтому немного сложновато, конечно. Так бы у меня окошко было бы приоткрыто всегда на вентиляцию. Потому что без кислорода мозг начинает засыпать. Так. Поговорили про это. ScrollView Effects. Это мы сейчас приступаем, да? То есть мы поговорили о том, как изображение, например, изменить размер. Говорили о том, как рамки и координаты внутри GeometryReader. Хотя, честно говоря, я бы пересмотрел, потому что я вообще ничего не помню. Я просто вижу, что у меня это уже сделано. Ну, я типа понимаю, как оно сделано. Да. Поэтому не буду сейчас это повторять и перейду дальше.
When we use the frame-in method of a geometry proxy, SwiftUI will calculate the view's current position in the coordinate space we asked for. However, as the view moves, those values will change, and SwiftUI will automatically make sure our geometry reader stays updated. Now, previously we used a drag gesture to store the width and height as an @state property. It allows us to adjust other properties based on the drag amount to create neat effects. However, with GeometryReader, we can grab values from a view's environment dynamically, feeding into absolute or relative position into various modifiers. Even better, you can nest geometry readers if needed. So one can read the geometry for a higher up view, and another one can read the one for something further down the tree. To try making some effects with GeometryReader, we're going to create a spinning helix effect by creating 50 text views in a vertical scroll view, each of which has an infinite maximum width, as they take up all the available screen space. Then apply 3D rotation based on their position on the screen. So we'll start out making an array of colors in our content view. We'll say our colors is an array of color equal to, let's do .red, .green, .blue, .orange, .pink, .purple, and then .yellow. And then in our view body down here, I'm going to say we have a scroll view. And this thing's going to count from 0 up to 50 with some index coming in. Inside there is our geometry reader with a proxy coming in. And now is our text. We'll do row number, our index. I give this thing a font of title, a frame with a max width of .infinity, and then a background color using one of the colors from our array. So we'll say colors index %7. Yes, thanks for that Xcode. Index %7. So it cycles through it again and again and again. Red, green, blue, orange, pink, purple, yellow. Red, green, blue, orange, pink, purple, yellow. Again and again and again. I'll then give this whole reader a fixed frame height of 40, like that. And now we want to apply to this some kind of, some kind of spinning helix effect, which means adding a rotation 3D effect directly below this background modifier here. We're going to say there's a rotation 3D effect, and the angle is going to be .degrees, and we'll use our proxies frame in the global namespace and read its minimum y, so its top edge, and divide that by 5. Take 1/5 of the scrolling amount, so it moves more slowly. The axis is fine at that, although with a whole bunch of extra zeros and some wonky indentation. There we go. And go ahead and try it out. Just run the thing back, see what you think. I'll press Command R now. And we should see I can just scroll around and they're moving and spinning constantly in 3D space. It works really, really well. So, as you can see, the ones at the very top, boom, they're dead on straight. The ones at the very bottom, they're of course flipped round, and the ones in the middle are spinning some way along the way. That's a neat effect. But it's also problematic because the views only actually reach their natural orientation at the very top of the screen behind the dynamic highlight of my iPhone 15 Pro here. It's really hard to read. To fix this, we can apply a more complicated rotation 3D effect that's going to subtract half the height of the main view. That means using a second geometry reader to get the size of the main view. So we're going to wrap our scroll view in a second geometry reader. This time I'll call its proxy full view, so we can distinguish the two very nicely. Like that. Full view in. Then the rest of the code is the same apart from this rotation 3D effect. This thing needs to subtract half the height of the available space. So we're still going to say use a proxy frame in global min y, it's fine. But we're going to make this slightly more complicated. Again, we're subtracting half that height to work with here. So we'll say our min y minus our full view dot size dot height divided by 2, and then divide the result of that by 5, like so. And so we're just moving things around a little bit. And with that in place, all being well, the views should reach their natural orientation near the center of the screen, as you can see. So as they're scrolling, boom, they're in the center, they align neatly. It's much more natural for human reading purposes, I think. You can see how lovely and fast it is. That's GeometryReader doing a great job. We can use a similar effect to create a cover flow style scrolling rectangle, which was all the rage in Apple land in the earlier days of iPhone and Mac OS. So we could say, for example, let's delete all this code. Here we could say we have a scroll view going horizontal with shows indicators of false. Inside there, I'll make a H stack with spacing of 0, and then count from for each. Let's do 1 to 20 with a number coming in. Inside here, this is where our geometry reader is, with a proxy coming in. And I'll say our text is number, like that. I'll add to this a font of large title so it's nice and clear. Do a little bit of padding. Let's add a background of fixed red is fine. And now we'll do another rotation 3D effect. Now this time, again with the wonky indents, thanks Xcode, this time I'm going to say our angle is going to be degrees of minus proxy.frameIn.global.min(x), so our left edge. But I want 1/8 of that, a very gentle rotation. The axis, firstly fix the indentation like that, and then delete the zeros. Otherwise, all good. Rotate around the y-axis. I'll then say each of our number areas has a fixed frame. We'll do width 200, height 200. I'll attach that same size to our geometry reader so it stops expanding to fill all the available space. Let's give that a try. Let's press Command R. Hopefully we'll get, there we go. Like as I'm moving around now, I can flip between views and they spin around beautifully. So that works nicely. These effects are fun effects, but they aren't exactly easy. Fortunately, SwiftUI provides better options. Let's look at them in the next video.
Все один в один. Поэтому даже не переживаем. Я забыл время поставить. Ну ничего, подправимся. Последнее видео в этом дне это ScrollView effects using visualEffect and scroll target behavior.
Previously, we looked at how to use GeometryReader to create varying effects based on where a view is on the screen. That code all works fine, and you'll certainly see it in lots of apps. But SwiftUI provides some helpful alternatives that can be much easier. First, let's look again at this current code we had from the end of the previous video. This makes a simple cover flow style effect using a horizontal scroll view, then 20 views or 90 views inside there, each with some text attached to it, and a very gentle rotation based on where they are in the scroll view. Let's press Command R and give it a quick try. Here we go. There's a lot of views, scrolling around neatly like that. Now, that all works. That's all fine. But what we're doing here is using GeometryReader around all our text, okay? And as a result, we've had to provide an explicit width and height for the GeometryReader so it doesn't automatically expand to take all the available space. Now, SwiftUI gives us an alternative called visualEffect, and it has a very specific purpose and a very specific restriction. It lets us apply effects that change the way something looks, which in practice means it can't do anything that affects the actual layout position or frame of a view. This modifier works in a very interesting way. We pass it a closure to run, and we'll be given the content we're modifying as well as a geometry proxy for it. And that content we're modifying, of course, is our view, but we can't just apply any modifiers we want to, like normally would. Again, we can't do anything that affects the actual layout position of the view. Fortunately, that still leaves lots of modifiers for us to use, including some that might surprise you. You can use rotation effect, rotation 3D effect, and even offset. So although they affect how views are drawn, they don't change the frame of the view. And so we can rewrite this code to use a visual effect instead. I'm going to go ahead and remove this geometry proxy from here, like this. And then, rather than applying this whole degrees thing here, I'm going to say, after the background red, this is where our frame's going to happen. We've got a fixed size at that point. And then we say, let's apply a visual effect. And this thing will be given the content we're modifying and a proxy we're working with here. And this is where we do our transformation. That's where we modify our code somehow. Now in our case, I'm going to take this rotation 3D effect here and apply it to the content inside the visual effect. I'll do content and then just paste that on in below. So it's this very, very similar layout. We still have rotation 3D effect, degrees, minus frame, and global, get 1/8 of that value, go around Y, but now it's modifying inside the visual effect modifier. So let's press Command R now. And you see it looks exactly the same. The result is the same, which is really, really nice. Now, yes, the code's a little bit shorter, but this is a much neater solution than using GeometryReader. You no longer have to add a second frame modifier to stop things trying to take up the full screen. This scroll view it is built can live alongside other parts of our SwiftUI layout without screwing things up. What we have now is a lot nicer, but with just 2 extra modifiers, we can make this whole thing look a lot better. The first is called Scroll Target Layout, which I'd like you to apply to the H stack. So down here, you are a scroll target layout. Now this thing tells SwiftUI we want to make each view inside the H stack be a scroll target, something that's considered important when it comes to scrolling around. The second is Scroll Target Behavior View Aligned, I'd like to add to the scroll view. So down here, you have a Scroll Target Behavior of View Aligned. And this tells SwiftUI should make the scroll view move smoothly between all the scroll targets it contains, which we just defined here as being every view inside our H stack. If you put these 2 together, the result is lovely. Run it back now. Here's number 1. If I pull number 2 across and then release it, it jumps to the leading edge. Go a little bit, it'll jump back again. It always jumps. There's always exactly 1 view at the start. No matter how fast or slow you go, it'll always end up with 1 view neatly at the start, which works much, much better.
Да, вот это последнее, Scroll Target Behavior. И какой еще там был модификатор? А ну напомните.
Start.
Scroll Target Layout. И Scroll Target Behavior. 2 таких интересных модификатора, конечно. Которые я бы, конечно, хотел использовать почаще, чем я это делаю сейчас. Окей, день 93. I finished. Updated for iOS 17. День 93. Так, день 93. Окончен. Что у нас за день 94? Челлендж опять какой-то. Не люблю эти дни челленджей, потому что... Хотя я его уже сделал. Я вот тут смотрю, что я его уже сделал, поэтому я быстренько его сейчас пройдусь. Итак, день 94. Это третья заключительная часть проекта 18 под названием Layout and Geometry. Надеюсь, этот небольшой проект по технике оказался желанным перерывом после наших длинных проектов приложений. Ну, как сказать. Но еще больше надеюсь, что вы действительно начинаете иметь хорошую ментальную модель того, как работает система лейаутов SwiftUI. Эта трехшаговая система макетов, лейаутов может показаться простой, но это потребуется время, чтобы полностью понять ее последствия. Что касается GeometryReader, это одна из тех вещей, это одна из тех вещей, без которых можно прекрасно обойтись. Даже не задумываясь, это нормально. Но иногда, просто иногда, вам нужна дополнительная мощность, которую вы не можете получить из контейнер Relative Frames или других опций возможностей в SwiftUI. И вот тут-то и GeometryReader может прийти на помощь. Так, теперь пойдем, сделаем небольшой тест на логику. Это у нас называется wrap up, правильно? Тут всего-то как раз есть wrap up. Стоп, я не то прочитал. Или то. Не то. Ну ладно. Вы готовы завершить наш последний проект по технике? Я надеюсь, что да, потому что предстоит еще один обзор, решить 3 новых задачи. Все задачи связаны с GeometryReader, потому ла-ла-ла. Короче, надо практиковаться. Как сказал Эми Морин, величайшие вещи в жизни, как правило, происходят за пределами нашей зоны комфорта, и сомнения в нашей способности выйти за ее пределы заставят вас застрять. Окей, неважно. Это мы уже прочитали. Что мы выучили, да? Конечно, структура непонятная, но ладно. Поехали, проходим тест. SwiftUI использует трехшаговый layout процесс. GeometryReader always takes up all available space in its parent. Первое. The parent proposes a size. The child chooses its own size, and the parent positions it. We can change the size just like any other view. When creating a custom alignment guide, we must provide a default value. SwiftUI has 5 built-in coordinate spaces. Это неправильно, да? Оно имеет 3. 2. Global Local. Еще есть named. Ну да. Это уже custom. This will be used if we don't attach the alignment guide modifier to a view. If you write text hello world background red, the text view is a child of a background. If you write the background is a child of the text. The color view is layout neutral. Parent view can force size on one of their children. We can align text in a H stack using the baseline of the first or last text view. Child use must always use less than or equal to the amount of space the parent offers them. Наверное, второе верно. Ой-ой-ой. This is important for creating visual alignments when working with different font sizes. Child users are welcome to request more space than was proposed. Ну да. And the parent must respect that. SwiftUI stores view positions and sizes as integers. Не уверен. The offset modifier changes where a view is rendered without actually changing its original dimensions. The baseline of text is the very bottom of the lowest letter. Нет. A view is always and exactly the same size as its body. A geometry reader is given one value inside its layout closure, which is a geometry proxy containing layout information. Unless we ask for a custom alignment, most parents always place their child views in the top left corner of their available space. Оно в центрах помещает, а не в левый верхний угол. In the center. We can use this to read our proposed size, our frame, and more. 9 вопрос. Text views automatically fit the size required to display all their lines. It's a bad idea to create custom alignment, guys. Нет, это неплохая идея. GeometryReader tells us the size that was proposed by our parent. The create coordinate modifier let us create a custom coordinate space. Нет. This lets us create relative layouts easily. We should use the coordinate space modifier for this. 11 вопрос. The alignment guide modifier lets us write custom code to calculate a view's alignment guide. Или we can't absolutely position views in SwiftUI. Да, можем. This is what the position modifier is for. This should be used together with whatever alignment its container is using. 12 последний вопрос. Frames provided by GeometryReader are automatically updated in a view moves as a view moves. When creating a custom alignment guide, it's recommended to use structs rather than enums. Наоборот, enums rather than structs. We can use this approach to create modifiers that change as the view moves. Окей, один только вопрос неправильный. Ответ, точнее, неправильный дан на вопрос. When we can align text in the edge stack using the baseline of the first or last text views. Это сделано. Переходим к челленджу. Итак, челлендж для этого дня. Put your content view back to the spin color rows example we had. With that done, make views near the top of the scroll you fade out to zero opacity. I would suggest starting it at about 200 points from the top. Первое, да? Background. Color. Следующее. Make views adjust their scale depending on their vertical position. With views near the bottom being large and views near the top being small. I would suggest going no smaller than 50% of the regular size. For real challenge, make the views change color as you scroll. For the best effect, you should create colors using color hue, saturation, and brightness. Initializer feeding in varying values for the hue. Each of those will require a little trial and error from you to find values that work well. Regardless, you should use max to handle the scaling so that views don't go smaller than half their size, and use mean with the hue so that hue values don't go beyond 1.0. Если правильно помню, то я это уже все сделал. Да. Да, дорогие друзья. Все уже сделано. Думаю, вот показывать или не показывать. Как будто надо показать, но как будто нет времени показывать. Как будто спать очень хочется. Окей, давайте покажу. Продемонстрирую, так сказать. Как оно выглядит, и заодно прочитаем еще раз. Вот так оно выглядит. Так, come on. То есть, когда я скроллю, меняется цвет, меняется поворот, меняется прозрачность. Да. Да. Причем весь градиент разбивается на... Точнее, весь список разбивается на нужное количество градиента. Если поставить меньшее значение в числе рядов, да, не 50, а, скажем, 10, то оно в 10 рядов уложится всеми этими оттенками. Да. Окей. На этом челлендж тоже, я считаю, что закончен, потому что он у меня выполнен. Только что закончил день 94, да? День 93, день 94. Где? Ну да, видно, что я это уже сделал. Драмер спрашивает, что игры для iPhone тоже делают Swift? Не уверен. Ну, то есть можно делать на Swift. Вот смотря какая игра. Если это игра какая-то такая прям 3D игра, видеоигра, я думаю, использую что-то другое. Хотя не знаю. Достаточно мощный язык, как по мне. Ну, есть разные фреймворки, там типа Metal для работы с изображениями, все такое. Ну, в смысле, с графикой. Там можно много всего делать. Ну, Swift там в любом случае это нативная разработка. Вот. Не знаю, я почему-то предполагаю, что есть инструменты для более простой работы с играми. Я думаю, какой-нибудь React Native используют или, не знаю, Unity, еще что-то, то есть именно игровые движки. А Swift можно использовать для простых игр по типу, там, не знаю, судоку, еще что-то. Ну, можно, конечно, заморочиться и написать что-то классное и свое. Вот, но вопрос целесообразности, как по мне. Так, какой у нас здесь был челлендж? Я, честно говоря, вообще не помню. Вот это было. Окей. Значит, челлендж я оставляю на потом. Тем более у меня 95-й день. Он и так уже сделан. И я на самом деле немного excited, потому что мне осталось 4 дня. Последний проект, да. И дальше подведение итога. Ну, вообще, давайте посмотрим все-таки день 95, чтобы мне голословным не быть. Окей, переходим к дню 95. День 95. Что он нам принесет? После завершения 2 крупных проектов и еще одного технического проекта пришло время сделать паузу и скушать Твикс. Ой, и поразмышлять над тем, что вы узнали. Более подробно рассмотреть несколько ключевых тем, затем взяться за новый челлендж. Это последний челлендж за эти 100 дней, поэтому я выбрал что-то приятное и гибкое. Можете сделать его за 30 минут, но если хотите, можете также выполнить дополнительные задания, основанные на том, что вас интересует. Это приложение дает все возможные возможности для разработки приложений так, как вы хотите, реализуя функции, которые считаете наиболее интересными и полезными для себя. Это чистый холст для работы, и нужно превратить его во что-то реальное. Нужно выбрать то, над чем вы хотите работать, разработать свой пользовательский интерфейс, исправить свои собственные ошибки и подготовить его. Не бойтесь совершать ошибки, потому что это нормально. Вызовы в жизни неизбежны, но поражение не обязательно. Итак, проработать 3 темы, одна из которых является вашей задачей. Окей? Давай будем прорабатывать, как на приеме у психотерапевта. Поехали. Что мы выучили? What you learned. We've had some long projects recently, but that's mainly a result of your SwiftUI skills really growing. You're way past the basics now. So you're able to tackle bigger projects that solve bigger problems. I realize that it can feel tiring working on these large projects, but I hope you're able to look back on what you've built and feel good. You've come such a long way. While completing this project, you also learned creating tab with tab view, using Swift's result type to send back success or failure, controlling image interpolation, adding swipe actions to list rows, placing buttons in a context view, creating local notifications with the user notifications framework. Using third-party code with Swift package dependencies. How to create dynamic QR codes. Attaching custom gestures to SwiftUI view. Using sensory feedback to make iPhones vibrate. Disabling user interactivity using allows hit testing. Triggering events repeatedly using timer. Taking scene state changes as our app moves between the background and foreground. Supporting color blindness, reduce motion, and more. SwiftUI's 3-step layout system. Alignment guides, and custom alignment guides. Absolutely positioning views using the position modifier. Using GeometryReader, geometry proxy, and container reality frame. Make special effects. And you also build some real apps to put those skills into action. It's been really busy, and I hope you feel proud of what you accomplished. Конечно. Ключевые поинты, да, ключевые точки. Полетели. Key points. Before we get on to the challenges for this project, there are 2 points I want to explore. Я это уже читал и проходил, просто хочу еще раз. In more depth to make sure you've understood them thoroughly. How map and filter fit into the larger world of functional programming and Swift's result type. Functional programming. Although I cover functional programming a lot in my book, for Swift, I want to touch on it here too, because we used it in briefly. We used it in briefly project 16 with the map method. This method is designed to let us specify what we want rather than how we get there. And both are part of what a wider programming approach called functional programming. To demonstrate how this approach differs from a common alternative called imperative programming, take a look at this code. Numbers, events, есть. That takes... Как я не хочу все это читать. Что оно, короче, здесь говорит? Создаем массив, проходимся по нему циклом и добавляем эти номера, эти числа. Те числа, у которых множитель, 2 множителя. Нет, которые делятся на 2. И в новый массив под названием целые числа. Нам нужно spell out exactly how we want process to happen. That code is easy to read, easy to write, and works great, but we can use functional programming method called filter and rewrite it as this. Let events равно numbers.filter и внутри $0 is multiple of 2. Now we don't need to spell out how things should happen and instead focus on what we want to happen and provide the filter with a test it can perform. And it does the rest. This means our code is shorter, which is awesome, but it's also improved in 3 other ways. It's no longer possible to put a surprise break inside a loop filter. Inside a loop, filter will always process every element in the array. This extra simplicity means we can focus on the test itself. Не хочу ничего читать. Хочу спать. Наверное, сейчас пойду спать. Уже 12 час как раз. Да, пойду спать. Завтра такой насыщенный день. To see the difference between map and compact map in action, try this example. Вот это я читал, но вообще не помню, чтобы я это читал. Вместо того, чтобы давать замыкание, мы можем вызвать shared function instead, which is great for code reuse. The resulting результирующее событие, результирующий massive events, целые числа, is now constant, so we can't modify it by accident afterwards. Using less code is always nice, but writing code that is simpler, more reusable, and less variable is even better. Functions that accept the function as a parameter or send back a function as their return value are called higher order functions. Higher order functions. Функции, которые принимают функцию как параметр, называются функциями высшего порядка. And both map and filter are examples of them. Swift has many more like them, but one of the most useful is compact map, which runs a transformation function over every item in an array just like map, unwraps any optionals returned by that transformation function, and puts the result into a new array to be returned. Any optionals that are nil get discarded. So while map will create a new array containing the same number of items as the array it took in, compact map might return the same amount, fewer items, or even none at all. That creates an array of strings that convert to an array of integers using map. Then compact map, when that code runs, events map will contain two optional integers, then nil, then another optional integer. Whereas events compact map will contain three real integers, no optionality, and no nil, much better. Result. Ой-яй-яй-яй-яй. Короче, что про result? Давайте переведем. Мы использовали тип result как простой способ возврата одного значения, которое либо неуспешно, либо успешно. Оно есть несколько важных функций, которые, вы надеетесь, полезными, скорее всего. Swift — это более продвинутая форма чего? Какой необязательности? Optionals. Optionals either contain some sort of value, integer, string, etc., or they contain nothing at all, and result also contains some sort of value, but now rather than nothing at all, for this alternative case, it must contain some sort of error. Behind the scenes, optionals and results are both implemented as a Swift enum with two cases. For optionals, the enum is called optional, and the cases are none for nil and some with an associated value of your integer, string, etc. And for result, they are success with an associated value of failure with another associated value. The only real difference between the two is that Swift has syntactic sugar in place for optionals, special syntax designed to make our life easier, because optionals are so common. So things like if-let and optional chain exist for optionals, whereas result doesn't have any special code around it. Second, as you've seen, result contains some sort of success value and some sort of error value. But if you need, if you have a need in these, needed, there are ways of using result and throwing function interchangeably. If you have a result and want to get back a do catch territory, just call the get method of your result. This will return a successful value if it exists, or throw its error or otherwise. As an example, consider code like this: enum network error, function create result, result string network error, return failure bad URL. Let result равно create result. That defines the sort of error, бла-бла-бла-бла-бла. Ладно, давай уже дочитаем. It creates a function that returns either a string or an error, but in practice always return an error. Then call this function and puts its return value into result. If you wanted to use the catch with that value, you could use get like this. Result.get. To go the other way, to create a result value from throwing code, you will find that result has an initializer that accepts a thrown closure. If the closure returns a value successfully, that gets used for the success case, otherwise the thrown error is placed into the failure case. Например, let result равно result. Замыкание try string contents of some URL. In that code, result will be a string result string error. It doesn't have a specific kind of error because string contents of doesn't send one back. The last thing you should know about result is that it has functional method you already used to include in map and map error. For example, the map method looks inside the result and transforms the successful into a different kind of value using a closure you specify. For example, it might transform a string into integer. However, if it finds failure instead, it just uses that directly and ignores your transformation. Alternatively, map error transforms that error type from one type to another, which can be helpful if you want to homogenize error type in one place. This is one of many things to love about functional programming. Once you understand it, that takes a closure and use it to transform stuff. Nature of map, you'll find it exists on array, result and even optionals. Да, ключевые эти долгие, конечно. И челлендж. Челлендж. Я не помню, делал ли я его полностью. Я сейчас открою его на всякий случай. Смотрю. Но, скорее всего, буду делать его не сегодня. Так, открыть существующий проект. Так. Смотрим проектик, какой у меня тут реализовано. Что тут вообще реализовано? И реализовано ли? Да, в общем, здесь нужно сделать программку, которая будет бросать кости. Вот это я пока что делать не буду. Оставлю на потом. Оставленные на потом эти буду держать вот здесь. Так, секундочку. Что-то у меня как будто уже сделано. Да. Let the user customize the dice that's rolled, how many of them and what type. 4 sides, 6 sides, even 100 sides. Show the total rolled. Store the result using JSON or Swift data. Anywhere They're persistent. Persistence Manager. У меня это было... У меня это было почему-то User Defaults. Окей. Add haptic feedbacks when dice are rolled. Вот это я еще не добавил. If for real challenge, make the value rolled by the dice flick through various possible values before starting on the final figure. Для челленджа, да. Не закончено. 4-5. Незаконченные задания. 4-5. When I say roll dice, you don't need to create a pencil 3D effect. Just showing the numbers that were rolled is fine. The only thing that might cause you some work is step 5, making the results flick through various values before setting on the final figure. The easiest way to tackle this is through a timer. Я сейчас только об этом подумал. Таймер надо использовать. That's get cancelled after a certain number of calls. While you're working, please take a moment to remember that accessibility of your code. Remember the accessibility of your code. Try using it with voiceover and make sure it works as well as you can make it. В общем-то, да. Я сделал так, что отображается в простом интерфейсе без кубиков всяких, но и не сделано 4-е и 5-е задание. Я это оставляю на потом, потому что в эфире я это делать явно не буду. И этим всем я хочу себя поздравить, улыбнуться себе и сказать, что я молодец, потому что я закончил день 95, вот, ну, помимо там некоторых челленджей, да, до текущего момента, которые у меня все зафиксированы, я их обязательно доделаю и закончу, и у меня будет еще после прохождения курса, у меня будет итоговый видос, где я покажу все законченные проекты, чтобы это было точно и так далее. И у нас остается один последний проект. Я сюда еще вообще не заглядывал, у меня нет этого проекта. Это будет полностью новое. Split View контроллер будем изучать и так далее, и так далее. Но что будем изучать, как раз поговорим и разберем в следующий раз. В следующий раз я планирую, что я планирую сделать. Я планирую полностью закончить вот эти 4 дня. Не знаю, получится у меня или нет. Может быть, я буду кусочками выходить. Я вообще хотел завтра это делать, но завтра не знаю, как получится, если только встану пораньше, потому что у меня достаточно загруженный день. Я, как говорят американцы, я excited about tomorrow. Много классных таких ожидается у меня дел. В общем, да. Но если возможность будет, я хочу закончить все вот эти 4 дня. И, возможно, даже сделать финальный экзамен. А что у нас на финальном экзамене? 100 вопросов? Да, 100 вопросов. Финальный экзамен. As it's a container, we stack can't have accessibility data. 3 text fields in the same stack are considered to be separate element if they are specifically combined. Вот, один уже правильно ответил. Alignment guide modifier let us write custom code to calculate views alignment guide. The views come with a built-in dismiss method that let us hide the view. Нормально. You can create round rectangle shape. Нет. Это создает капсулу. You can place optional views directly into... Это верно. Вот уже 4 решил. SwiftUI let us animate. Ну, короче, я уже начинаю вперед немного забегать. Я поздравляю себя, я поздравляю вас. И на этом текущий эфир я также закончу. У меня сейчас как раз половина 12 ночи, вечера. Хочу сегодня пораньше лечь спать. JavaScript, к сожалению, извините меня, пожалуйста, второй или третий подряд день уже его не будет. Ну, по очевидным причинам. Вот. Спать тоже иногда надо. А так, спасибо всем, кто смотрел это в эфире. Также, если вы это смотрели на Ютубе, если вы это смотрели, если вы еще не подписаны на мои ресурсы, на мой YouTube канал, на Twitch, на другие ресурсы, то можете сделать это, можете подписаться. Ссылка на мои ресурсы сейчас летит в чат. И также она будет закреплена где-нибудь в описании. Но также вот здесь внизу чата она появилась. Вот, ее можно здесь посмотреть. Окей. Я вот так вот еще сделал, чтобы было видно получше. Все, я засыпаю. Нет у меня каких-то сил. Я уже даже не сильно соображаю, что сейчас происходит. Вот. Но соображаю, что я дошел до того, на чем я остановился в прошлый раз. Очень я доволен. У меня это заняло не так много, в принципе, времени. Сколько, если это 20-й, ну, по сути, что, 3 недели? Ого. Хотя, не-не-не, я же не каждый день выходил. Так что, может быть, даже больше. Может быть, 2 месяца. В общем, ладно. Что хочу сказать. 28 февраля у меня заканчивается. И будет начинаться сейчас уже 1 марта. И если я завтра успею вот это все сделать, это будет означать то, что я буду считать, что я выполнил одну из очень больших задач на февраль. Это пройти до конца 100 дней SwiftUI. Для меня это будет большое освобождение из головы, потому что я буду знать, что я этот курс полностью закончил, полностью прошел, и могу двигаться дальше. У меня не будет этого незакрытого гештальта. Вот. А так, еще раз всем спасибо. Подписывайтесь на каналы, подписывайтесь на мои ресурсы, пишите комментарии, ставьте лайки, делитесь с друзьями. Это поможет, все это поможет развитию моих ресурсов, моего канала, моему личному развитию. И также поспособствует выходу нового, более интересного контента. Да, так что еще раз всем спасибо. Увидимся с вами в следующий раз. Пока.